Problem 2 is where we're going to get a little more complicated. All right, so here, now I'm going to go back to the presentation from last time because there was something I skipped and now it's time to talk about it. All right, so last time we talked about a couple of different algorithms for loading the chalk. The simple algorithm, where we just went down the list in order, and then the greedy algorithm, where we always loaded the heaviest remaining weight that would fit on the truck, a way of trying to load more weight on the truck. And we saw that neither of those will give us the optimal solution. So is there some algorithm that will always give us the best possible solution? It'll always load the maximum amount of weight possible. Yes, but it's going to be a really inefficient algorithm. Okay? It's going to be what I'm going to call a brute force algorithm that you probably wouldn't use in practice because it would become impractical if you have a large number of items. But just to show you, and also to use it as an example of program structure, but just to show you it is possible. All right, so how's this going to work? Well, if you think about it, let me back up to one of these earlier slides. Let's go all the way back to the greedy algorithm with sorting. All right. So why did this work better than the simple algorithm? Well, because we sorted the weights, and now when we go through them in order, we'll always be getting the heaviest remaining weight. Well, we could think about it even more. Say, well, you know, what if we just happen to have the 700 here? Let's say that wasn't even there. Let's just move it to the end of the list or something. And then the 300. Let's say this was 300 and that was 400. Well, it would just so happen that we would luck into the optimal solution, because it just so happens the 700 and the 300 are the first two items in the list. We're going to hit them first. We get the optimal solution. So the idea is, well, what if we try all possible permutations? We just reorder the weights in all possible ways and apply our simple algorithm to each one and see what gives us the best result. One of those will give us the optimal solution. So that's what we're going to do. All right, so here's how it's going to work. So of course, we start out, we haven't loaded anything yet. So far, the best result we have is nothing. We generate the permutations of the weights. So what I mean by that, there's a built-in function in MATLAB to do that called perms. Let me show you how it works. Let's just generate some weights here. Oh, that's too many. Let me just do 3. All right. Just so you can see it, I'm just going to do a small number of weights. But if I do perms of that, you see what it gives me, a matrix with all possible permutations, okay, all possible orderings of these weights. How many permutations do you get? N factorial, where n is the number of weights. Right, so you can see why this becomes impractical if you have a large number of weights. So up here where n is 10, what's 10 factorial? 3,628,800. All right, so even with only 10 items, you get over 3 million permutations. And this blows up very fast. So this is only feasible with a relatively small number of weights. All right, but having done that, what are we going to do? Well, now we're just going to loop through all the permutations and apply the simple load algorithm to each one and see what gives us the best result. All right, so start at the beginning of the list. So this could be a for loop. Apply your simple algorithm to that first permutation. That's determine how much weight that loaded. And then our new best result is, well, either that weight or the best previous one, whichever is more. Okay, so in other words, each time through the loop, you ask, is the result that I got this time better than my best previous result? If it is, then that's your new best result. All right, and here's an efficient way of doing that in MATLAB with the max function. And then you go to the next permutation. And n factorial, as I said, is just the number of permutations. Okay. All right, so you can do all this, okay, again, in a flow chart. I'm showing everything very explicitly, but you can do all that with a for loop. Okay, you don't actually have to do permutation equals 1, permutation equals permutation plus 1, because that happens automatically with the for loop. And the same here. Okay. You don't have to explicitly say n factorial anywhere. That's just how many permutations you're going to have. So the thing that people get hung up on the most is indexing. It's not real complicated, but maybe you just haven't had enough practice with it. So let's say, let me go back to MATLAB for a second. All right, so let's call this, I don't know, weight perms or something. Okay, so I've got this matrix, and I want to pass one row at a time. Okay, so you've got to get this indexing right, because here's the set of weights that you want to pass to the function. And then the second time through the loop, you want to pass that row. All right, so one row at a time is going to be weight perms, whatever row it is. So let's say your loop counter is called R, or let's say it's called row, colon. All right, so that's what you're going to pass to the simple load simple function. I think I said to call it load simple. So it's going to look something like this. Right. That little detail seems to be the thing that hangs people up the most.